Okay, so next, we're going to start simulating TCP/IP networking. So this is an example. So this is how TCP/IP network works on the internet, especially for internet connectivity. Okay, so a simple TCP/IP example. So a user hosts net.a.lab.edu, uh, or the net A computer makes a web access to URL. So the computer on the left side creates a web request to the computer on the right side, which is net B, which is our web server. So basically, the web server provide the service being requested by net A. So if you have the web request, we have the web reply. So basically, net A makes a web access to URL net-b.lab.edu/index.html. So that resides on NetB server. So since NetB acts as a web server, it provides service to web client. And what actually happens in the network? Okay, so from net A, the let's say for example, if you are using Google Chrome, so basically the Google Chrome creates an HTTP client program that will generate HTTP requests. Okay, so the browser creates the HTTP requests, and for a web server, so the web server runs an application which can provide an HTTP service. For example, a WAMP service, WAMP server, so that can be used to create a program or a database that can provide an HTTP service or even an HTTPS service. Okay, so the HTTP client sends an HTTP request to the HTTP service server. So therefore, if there's a connectivity, the HTTP server will respond with the HTTP response. Okay, so from HTTP to TCP, to send requests, HTTP client program establishes a TCP connection to the HTTP server. So just like with the OSI layer, that falls under the session layer. So it establishes a session or connectivity to the destination. Okay, and basically, if there is a connectivity, the network prepares for a TCP connection. Okay, so meaning to say, yes, we can there is a connectivity between net A and net B. So, it is time to define kung ano ba yung service. Okay? So, let's define the service that we are going to send on the network. Okay. Kaya lang, the TCP does not recognize host names. Okay? So, everything should be converted into a machine understandable language. And for data transmission, so basically there are two things that must happen. Okay? So the name net-b lab.lab.edu must be translated into a 32-bit IP address. Okay? So for the TCP to recognize the location of NetB server, it must be translated into a 32-bit IP address. Same as well, para ma-define yung service, so basically the NetB must be identified by a port number. Okay, the port number defines the HTTP service. Okay? So, the translation of hostname netb.lab.edu into an IP address is done via database lookup. Okay? So, from the HTTP client, it will look kung ano yung nakalagay na DNS server on the computer, yung configuration na, di ba, we have the IP address, subnet mask, default gateway, and DNS. So, basically, the DNS IP is a DNS server which is located anywhere on the internet. So, that holds different or list of different domain name with corresponding IP addresses. So just like in this diagram, we have the HTTP client. It looks on the DNS server 128.143.136.15, just like Google DNS, the 8.8.8.8. So it is a server which holds different IP addresses with corresponding domain name. Okay? So, na-detect or na-check on the DNS server that net-b.lab.edu do have an IP address 128.143.71.21. So, the distributed database used is called the domain name system. Okay? So, all machines on the internet must have an IP address. Okay? So, lahat ng websites, web servers do have corresponding IP addresses, and domain names do have corresponding IP addresses. So, in our example, the net-a.lab.edu do have an IP address 128.143.137.144, and net-b.lab.edu to have 128.143.71.21. Okay, so finding the port number, most services on the internet are reachable via well-known ports. So, well-known port numbers of some of the most popular services are FTP, or the File Transfer Protocol, that's port 21, Telnet, that's port 23, SMTP, that's port 25, or the Small Mail Transfer Protocol, Simple Mail, Simple Mail Transfer Protocol, that's port 25. Finger, we have 79, HTTP, that's 80, NNTP, that's 119. Okay, and there are several other services available on the internet, which do have corresponding port number. Okay, so the HTTP client at net.a.lab.edu requests the TCP client to establish a connection to port 80 of the machine with address 128.141.71.21. So we have the HTTP client requesting a HTTP request. So this time, bago dumating dun sa server, sa destination, it will request a port 80 service. Okay, so through a TCP client or TCP connection. So, nade-define na dito kung ano yung service na ginagamit mo through port number. So, para alam, pagdating sa destination, alam na nung server kung ano ba yung kailangan mo. So, the destination already know what service is being requested on the network. Invoking the IP protocol. So, the TCP IP client at net A sends a request to establish a connection to port 80 at net B. So, meaning to say, you have a TCP connection, but this time, that's on port 80 on net B. So, after you establish the service, so this time you're going to establish the destination. So, this is done by asking its local IP module to send an IP datagram to 128.143.71.21. So this time we're going to attach the on the data, on the TCP IP data. So dadagdag na yung IP datagram or the IP address of the destination. Syempre, we already established a connection, and we established connection on port 80, and that defines the service. So this time, saan naman natin dadalhin yung data? Where are we going to send the data? And that is through IP datagram or the data header na 128.143.71.21. Okay? So, sending the IP datagram to an IP router. So, net A can deliver the IP datagram directly to net B only if it is on the same local network. Okay? So, it can directly connect to the network if net B is on the same network as net A. Okay? But net A and net B are not on the same local network. So how does net A know this? So net A sends the IP datagram to its default gateway. So ang nangyayari is, so if the network or the destination na hinahanap mo or na hinahanap ng net A is not part of its network, so basically it will forward the packet or the data to the default gateway, which is an IP router. Okay? So, the default gateway for net A is router 128.143.137.1. So, doon niya dadalhin yung data para hanapin sa labas. Okay? So, that is the function of the router. If a network address is not part of the network of the client, basically, it will look for the destination outside of the network. Okay, so that is the function of the router. Okay, in this example, we have net A. It will forward the traffic to router 1, 128.143.137.1 because net B with the IP address 128.143.71.21 is not part of the network of net A. So meaning to say magkaiba na silang network. So basically, if that will be the case, if the destination is not part of the network, so it will forward the data or the traffic or the packet to the router or to the default gateway. So, okay, babato niya on the default gateway palabas para hanapin if the destination exists. Same as well with router 2. So, if net B will connect to net A, so the packet or the data will be sent to router 2 first so that paglabas sa router 2, hahanapin niya yung destination. Okay, so that is the function of the router. So to look for a network address or a computer or server which is not part of the network. Okay, so aside from adding IP, since we already know that the destination because of the IP address, so basically, when you transmit the data, especially on the physical aspect of the infrastructure, hindi naman niya ma-define yun through the IP address because IP addresses are logical. Okay, bababa tayo on the physical level of addressing, which is what we call as the media access control. Okay, so the media access control or the MAC addresses are fixed on the devices. Okay, para mas makita niya on the physical level kung nasaan yun. So basically, the IP address will be converted into MAC addresses. Okay, and that is what we call as the address resolution protocol or the ARP. Nangyayari yan sa mga switches. Okay, the ARP happens on switches and mostly on switches. It translates the IP address with the corresponding MAC address. Halimbawa, MAC address 00A02471E444 do have a corresponding IP address 128.143.137.144. So basically, the MAC address there is fixed on net A. Okay, and same as with the router, meron siyang MAC address. Okay? So, magko-communicate na siya on the media access control level or the physical address level. Okay? So, because we are dealing with transmission on the physical level. Okay, hahanapin niya yung mga devices na dadaanan ng yung packet or data papunta using the MAC addresses on the physical level. And the ARP is the one responsible for converting those IP addresses into MAC addresses or looking for the MAC addresses corresponding to an IP address. Okay, so invoking the device driver. So the IP module of net A tells its Ethernet device driver to send an Ethernet frame to address 00EO F923AE8N20. Okay, on the data link layer, so the data link layer provides the frame. Okay, and the frame do have the corresponding MAC addresses information because at that level, at that layer, the transmission will start converting it into physical network transmission. Okay, it will look for the destination address using MAC addresses. The source and destination addresses are now presented into MAC addresses. Okay, so the Ethernet device driver of NetA sends the Ethernet frame to the Ethernet network interface card. The NIC sends the frame onto the wire. Okay? Yon. So, since the IP is now converted to the MAC address, so basically, your network interface card will now release the data in electronic signals or into the wire. Okay? So, you already have the MAC addresses information on the physical level. You are now going to transmit the data physically. So, into electronic signals. Okay? So, that's forward. Then that's how the process of TCP/IP works on the network. So from the client, it will go to the router, it will go to the destination. Okay, so uh through through a service, to a service request, going to the TCP connectivity, going to the TCP port, going to the IP address, and going to the MAC address, and until to the physical connectivity. Okay, same as well on the other side, from router 2, papadala niya yung data or packet coming from the other side of the network, which is net A. Then there's also established ARP, then IP address going backwards or reverse nung 7 layer. Okay? So that's how TCP/IP simulation works, and that's how just to give you an idea how TCP/IP works on the internet. Okay, so that will be all for my discussion for today. So kindly check your assessment task uh, after this lesson.